Hi there. When we left off yesterday, we were looking at this formula. This is on page 113 of our text, and this is how bond traders come up with an estimate of yield to maturity. Okay, so I demonstrated how this problem works in general, and then I said let's use our Coca-Cola problem, and we know it's a 3.3 face value, coupon value bond, and that it has a yield to maturity of 2.42. So let's do the math and test this out. We know that this bond was listed, a $1,000 bond was listed with a selling price of $1,068. That means you have to pay a slight premium for that bond, and paying a premium, paying more for something than its base value that you'll get when it matures, means that that cuts into, it reduces your overall yield. Therefore, it makes sense, okay? If you have to pay a little bit more for this Coke bond, $1,068 for a $1,000 bond, it makes sense that your yield is not 3.3%, it's lower. We're going to prove that it's 2.42% prox by using this approximation formula. So I plug in the numbers into this formula on page 113. Okay, first of all, we take the amount of interest you will receive for one $1,000 bond for this Coca-Cola issue. That is $33 a year. It's a 3.3% bond. Okay, we add to that a fraction. Now the numerator for that fraction is $1,000, the face value of the bond, how much you'll get at maturity, minus how much you pay for it now. Sometimes more than 1,000, sometimes less than 1,000. In this case, it's more. We take that difference and divide it by the amount of time remaining until maturity. This is, at the time of this writing at least, it was 8 years. Okay? Add all that together, and that gives you the numerator of the overall equation. The denominator is going to be the weighted average of the purchase price of the bond and the face value of the bond. Okay? We give them, respectively, a 60-40 weight. So we're going to take how much you pay for that bond, that's $1,068, times 60%, 0.6. We take that number and we add it to the other factor with a 40% weight. The face value of the bond, how much you'll get when it matures, that's $1,000. That's almost universal. So that's 0.4 times 1,000. And if you math all of that out, remember the correct order of operations, ladies and gentlemen, you're going to get, my timer's not working here. There we are. You're going to get 2.4. Okay, so close enough? Yes, the YTM listed in the bond listing that I gave you on page 108, I think it was, yes, is 2.42. The approximation works. Friends, I'm going to need you to know how to do one of those for me, okay? All right, we go on then. And I'm having some trouble. There we are. Okay, there's the Coca-Cola example. Okay, now please remember, whenever you discount bond values, you will have to use the market's required rate of return, R sub I. Okay? Bonds are very easy to determine, math-wise, because they have a finite date for the most part. You know when they're going to mature. That means you can take all the future cash flows and discount them to today, and if you need to buy one of those bonds, that is the amount you should pay today. Okay? Now sterling, remember, it's got 15 more years to go until it matures, and it is paying 8% per year. That's 80 bucks. Okay, here's what you do to price a bond, friends. You discount all future interest payments to today. Those are real cash flows. You know what they're going to be, $80 a year for X number of years. Discount them. Isn't that an annuity? Yes, it is. Number two, take the principal. You're going to get that back. They owe you the $1,000 at the end of the bond life. Discount that. That's a one-shot deal. Don't use an annuity for that. That's a present value of a single amount. Now that you've discounted everything to today, number three, you add them together. Friends, that's the price of your bond. Okay? The present value of expected future cash flows. Okay? Sometimes rates will go up, sometimes down. So price out your sterling bond. If rates go up to 10%, price it if it goes to 6%. Remember, you're not going to use 8% unless that happens to be the required rate of return by sheer coincidence. Never use the face rate otherwise. Here's a general rule, friends, in blue. When interest rates are rising, prices of bonds will tend to drop. Why? Because you can take the same amount of money and go buy something better. Therefore, if you're going to buy a bond that's paying something less, the pot has to be sweetened with a discount. Therefore, bond prices drop. The inverse works as well. If rates are decreasing, you've got a bond that's worth more money. It's paying a better rate of interest, so it will trade at a premium. Its prices will rise. That's our general rule right there, okay? All right, please remember you can always recast all of the math for semi-annual payments. I will not hold you responsible for this, okay? Please remember, however, that the more often you compound, the higher the cash flow will be, because interest on interest is working more often. Study this slide for me, but I'm not going to ask you a problem about semi-annual compounding on a bond from Chapter 5, okay? All right, now let's go over here to a spreadsheet, okay? I said, what if interest rates go up to 10%? And by the way, this is in the book. This is all going to be on page 115, okay? Okay, interest rates go down to 6%, okay? And interest rates just happen to be 8%, same as the face, purely by coincidence. Okay, now here's how you value bonds, friends. Okay, when I give you a problem about valuing a bond, I'm going to have to give you the required rate of return. I'm going to have to give you the maturity, how many years to maturity. I'm going to have to give you the face value of the bond. When I give you all of those factors, you can apply the 3 steps I just gave you. They're also in the book on page 114 to come up with the value of that bond today. Okay, so let's start by looking at interest and principal. Okay, so whenever we do this, we'll do it in 2 steps. Principal, let's try spelling that right, and of course the total. Okay, now looking at page 114, 115, I will not call up my tables, I'll just refer to them, okay? But now let's look at the first scenario. Let's assume that the market rate of interest, the required rate of return, R sub I, has gone up in the inevitable fluctuations to 10%. You're holding an 8% bond. Okay, in the 10% world, you've got something that's paying 8. That means if you want someone to buy it from you, you're going to have to give them a discount. It's going to trade for less than 1,000. That only makes sense. Okay? Here's how the math works. Now, every single year, the interest, I always do the interest first. You don't have to, but I do. You know it's going to be 80. 80 bucks. You're going to get 80 bucks every year. Now, interest is an annuity. Every single year, you're going to get 80 bucks. So you can do this calculation 15 times, or knowing about Table D, you run and grab Table D, the present value of a stream of payments, an annuity, and you look up the 10% factor. Don't use 8%. You use the required rate of return. Go and look up the 10% column, 15 more years to maturity. You'll find that the factor is 7.606. My book rounds it off to 3. My tables go to 4, so I'm just going to stick with 3 if you all don't mind. And that factor is 608.48. Okay? $608.48. Number 2, you've got to discount the principal because you are going to get that money back. The problem is you're not going to get it back until 15 more years go by. So take that $1,000 that you will get back in 15 years, the value of the bond, the face value. Go to table number 2. That's a single amount. You're only going to get repaid once. Go to table number 2, or table B if you will. 10% column, 15-year row, and you're going to find that it's about 2.39. Again, my apologies for the fact that this is 3 decimal places instead of 4, but you know what? I'm going to stick with it because that's what's in the book on page 115. So that number, of course, is $239. So to value this bond, now that we've discounted everything, you can combine these factors, add them together, and you get $847.48. That is how much that bond will sell for today, all things equal. Okay? Now, number two, I'm going to take the same data, I'm going to replicate it, and this time we're going to say, well, what happens if interest rates have gone down in the general market to 6%? Okay? Well, now you're holding an 8% bond in a 6% world, therefore you're holding something of higher value. If someone wants to buy it from you, you're going to make them pay extra for it. Okay? Because if they buy that bond for $1,000, you've got your $1,000, where do I put it now? Oh, it's got to be something at 6%. You don't like that. So if you're giving something of value up, it's going to be at a premium. You'll make them pay for it. So go back to Table D, and we're going to look up $80 that you get every single year, and this time the factor is 9.712 prox. Okay, that number is 776.96. Okay, we do the same thing with the principal. $1,000. Look up Table B, and you're going to find that it's about 0.417. All right, that's easy enough. 417. So your bond is going to sell for $1,193.96, just like we thought. Okay, last but not least, I'm going to say to you, what happens if rates just happen by sheer coincidence to be the same as the face rate of your bond? Okay, so let's do one more copy and paste just like that. And go look up the factors in Table D and Table B, okay? This time around, you've got $80 multiplied by 8% column, 15 years. You'll find that the factor is 8.559. And that maths out to 684.72, roughly. These are approximations. Then you do the same thing with the principal, this time using Table B. You find that the factor is for 8% and 15 years, 0.315. That's $315. And look, it's roughly the same. There is, of course, a slight rounding error. Don't worry about it, okay? Please keep this handy as a study tool and as a reference tool, okay? All right, I'll save that for you. And the very last topic that I'm going to get into is this. I'm not likely to ask you quiz questions about these, but I am compelled to mention them. They are in the book, and more importantly, this is something that you want to know as an individual investor, okay? You do need to know about strips, okay? Beg your pardon. Zero coupon bonds, affectionately called zeros or strips, it stands for something like separately traded receipts for interest and principal securities. In the investment world, they get very cute. Sometimes they really have to reach for these acronyms, okay? And no one calls them strips. We call them zeros. Okay, here's the deal, friends. These, I think, were invented in the late 70s or early 80s, and a zero coupon bond doesn't pay any interest, okay? What you're going to do is you buy these bonds at a very deep discount, okay? They don't pay you interest. So what you do is you buy a $1,000 bond for, say, $400, and you hold it for X number of years. And the way you make your money is that $400 price that you pay will grow and grow and grow to maturity. And when it hits that maturity date, it's worth $1,000. So you bought something for $1,000 for $400, and it grew and grew over time, and your profit was the $600 spread. That's what a zero is. Okay, coupon is a really old term. In the old days, before the internet and e-commerce, if you had a bond, it would have a whole bunch of little receipts on the side called coupons. You'd clip them, coupon clippers, right? And you'd mail it, and they would send you a check. Okay, the bond issuer would, or the agent would send you a check. Okay, so coupon is kind of an obsolete term. All right, so there's no interest on these things, therefore zero coupons. Okay, so remember, you buy it wicked low, and it grows to 1,000. That spread is your profit. Okay, so these are fairly new. Now, what is the problem with zeros? The reason I mention them is because these are a wonderful thing to include sometimes in your IRA. Okay, Now the problem with zeros is this. You make your money on what they call the original issue discount, OID. Okay, so now you know how your bank sends you a little interest slip, a 1099 interest every year to tell you how much interest you earned. You get one for dividends, you get some for trading stocks. It's a non-employment proof that you have received income, so the Internal Revenue Service knows that they should be watching for a tax on it from you. Okay, so the problem with these zeros is that the OID, its growth from 400 to 500, later on 500 to 550, 550 to 650, that's taxable. All right? Now, you haven't gotten any cash. This is an investment you're holding, and now you've got to pay a tax. Okay, so zeros can be a trap in that respect. Okay, you've got to pay a tax with money you haven't made yet. At least you haven't made it realistically. You've only made it on paper. But if you put one of these zeros into an IRA or a Roth, excuse me 1 second, please. Okay, my apologies, I had a phone call. Okay, so as you make money with this OID, you're going to receive a receipt every single year saying your bond increased by this amount, and the Internal Revenue Service will tax you on it. A copy is sent to the IRS, okay? So that's a problem. If you can pay the tax, fine. But why are zeros a good idea? Because by putting them in an IRA or a Roth or a non-taxable or tax-deferred vehicle like those, and I'm certain you all have heard of those, or have some already, the tax is not an issue. So if I were to buy a zero, it would probably be for my IRA or my Roth, okay? So please remember what a zero is, not for me, but for you, because I'm not going to ask you about zeros in this course. And when you see the term OID, it simply means original issue discount. You bought something really, really low, and you're going to make your money by the fact that it grows to a maturity value. Okay? That's what a zero is. And having said that, that brings us to the end of Chapter 5. Don't save. And I'm going to post this worksheet, and please study this carefully. I'm going to start my video lecture series on Chapter 6. And please hang in there, friends, because at this point we're just about 2/3 of the way through the course. There is indeed light at the end of the tunnel. Okay? Take care. Please enjoy this little cool break now that the heat wave appears to be over, and have a nice day. We'll see you.